Hey everybody, welcome back to our weekly stream. My name is Johannes Verweijden. I'm the principal instructor for Deep Dives EU with a lengthy background in development, data science, and analytics and stuff. And with me, I have my good friend Mikko Nieminen with a similar background. And Mikko promised this week to go through the news. So what
Yes.
did you find for us?
I didn't find too much, or not. I didn't find too many interesting pieces of news, but I have something from AWS, and the first one. Well, we have the 2024 announcements here on the list, and the first one is on the list is about Athena being available in the new region in Canada, Calgary.
Yeah.
And we were wondering last week why, for example, AWS Backup was just announced there, even though the region was already up and running. And we figured out that, okay, new region, not all services will be available immediately. And surprising number, and surprisingly, some real core services are not available in the very beginning. But now we see one more, Amazon Athena.
Yeah, I think core services are like literally, if you take it, then they are the ones that are always available. I think it's like EC2, EBS,
S3,
S3, yeah, something like that. And then the rest of the services that are actually built on those core services.
And they are using those the real core services, but still, from like my point of view, for example, like last week we were talking about AWS Backup, kind of seems like a very important service to have. But nevertheless, so there are new services in Canada West or Calgary. And another interesting piece of news was DynamoDB now supports resource-based policies.
Yeah.
And so this kind of when I read that headline, I was like, or title, like, but wasn't it always like this? But no, it wasn't.
No.
So this is a new thing.
So normally with DynamoDB we had IAM, identity-based policies only. Now, what is the difference? Why would you use resource-based policies over identity-based policies?
Good question. Something to do with management, probably.
There's
or cross account or cross.
Exactly. There's one field in resource-based policies that doesn't exist with identity-based policies, and that field is
the whoever is allowed to access.
Yeah, the principal.
Yeah.
And in IAM, you implicitly define that principle by attaching a policy to an identity, right? And then if you don't have that identity, if that identity is in a different account, you can't do that.
Yeah, so then you would have to do some trickery. Some proxies there in between or something.
Yeah, or like cross-account role access, which is a little bit of a pain, especially if you have, let's say that DynamoDB is like your log sync, right? So you're just logging from everywhere to that, and you have 100 accounts. So you need to create 100 cross-account roles to be able to write. So now,
not perfect. So this is easier then.
Yeah.
Okay.
Really good stuff. Finally.
And another DynamoDB related news was DynamoDB supports AWS private link, and this was a bit tricky. So to be able to connect to DynamoDB from within your virtual private cloud, for example, your VPC, without the traffic traversing through internet, or at least conceptually, then or without the traffic leaving AWS private network, then you would have to have an endpoint in your VPC that would then connect your VPC to this service. In this case, it's DynamoDB.
Mhm.
And there are two kinds of endpoints, gateway and interface endpoints.
Yeah, I'm thinking free and paid for.
Yeah, so gateway endpoints are free. You just set them up, and then they are free to use. There's one limitation, a rather big one, or several limitations, but one of them is that gateway endpoints are only available to be used with DynamoDB and S3. And I really had to dig deep because I was very certain that the interface endpoints were available with DynamoDB as well, and could be that I was mistaken. But now they are available. But that's why I was a bit surprised by this news item, because I thought this was already the case.
Yeah, I think in some of the materials that we deliver, we kind
It's a
of
bit vague about that.
Yeah, we kind of talk about gateway and interface endpoints as being possibilities for S3 and DynamoDB,
Exactly.
whereas the rest of the services would only have possibly an interface endpoint. You want to refresh people by telling them how their function differs?
It is about how the traffic is routed, and it is about how you can use them from the outside.
And that's why, or the reason why you can use them from the outside is because of the way the traffic is routed. Right?
Yeah, so interface endpoints work with DNS, using DNS, and gateway endpoints use route tables of your VPC.
Exactly. So the VPC endpoint consumes one IP address in your VPC, and then if you have something like direct connect set up, then it's fairly simple for you to use that.
And you can, and here's the good thing: you can, from your on-prem, you can use now DynamoDB without the traffic going through the public internet. So you can access your own DynamoDB table from within your on-prem environment.
Yeah, previously you would have had to have some kind of a remote proxy there. Reverse proxy there, taking care of that or something like that.
So anyway, this was a good in this sense. This was a good piece of news because I had to dig a little bit deeper and really go through the material and like try to figure out why this is a news item here, because I thought this was already the case that DynamoDB supports interface endpoints, but at least now it does. One more is the never ending or increasing Java version numbers. And when we started with Johannes, we were using Java 1.1 or 1.2.
1.1.8.
Yeah, 1.1.8. And then the version numbers were changing every now and then. I don't, but of course it has changed now. And now we're running 22, well, more than 22. I've completely lost track here. So I did my Java 11 certification a long time ago, and then basically after that I've been focused with AWS stuff and not programming that much anymore, and I've completely lost the version numbers. So, but it was fun to see that. Okay.
So your Java certification is only worth 50% now.
It's only So I know basically half of that.
Yeah.
Okay, so that was kind of a fun thing to notice. I had this Athena part here as well. We covered that as the first thing, but then something completely different. NVIDIA Blackwell platform. So new hardware from NVIDIA, and supposedly much more energy efficient, faster and more energy efficient. Usually good things to have. And so what does this mean, Johannes? why is this a big piece of news? Why is this news? Is it
Well,
just marketing?
well, I don't know if you've been following. I can pull up the Nvidia stock price over the past 12 months.
Okay, I'll
Kind of
find that.
related.
Yeah, the stock went up threefold in quite a long, short period.
Yeah. So a little bit of backstory here. So we've been living in this kind of transitioning work from normal work to AI powered work for a while now, and lately, as we have discussed previously, large language models have started to become really popular, and we found really good use cases for them. And now, that's that's a good picture. Like just take last year or two.
Last year, it's still pretty good.
Yeah.
And like
it's crazy, right? So why is this true? Well, how do you know the name Nvidia? What does come to your mind?
graphics cards,
Yeah. So GPUs.
GPUs. Yeah, but when you ask it that way, then it's old school graphics cards. That's where I know the name from.
And as we discussed previously, as it happens, these kind of 3D graphic cards do very similar operations than what is needed when training a neural network. So lots of matrix operations, and they are good. Those 3D graphics cards are very, very, very fast because they have their own local memory. So they can read and write operations directly into their own local memory. They don't need to go via the system bus to the system,
And they do a limited set of things, unlike
the
CPUs.
main kind of, so because of the von Neumann architecture of computers, we're kind of always limited by the clock speed of the system bus to be able to fetch data from the central memory to the CPU. And in the CPU world, we try to work around that using caching, like 3 layers at least of caches nowadays. But still, the problem is that these 3D models originally for games, they are so big that they don't fit into the cache. But if the GPU has its own local memory that runs on a separate cycle compared to the system bus, then the GPU can optimize how it accesses that memory and can work a lot. So basically, memory access is the bottleneck. Like normally for our normal users, maybe disk access is the bottleneck or network access is the bottleneck. But when you're doing 3D graphics, it's actually memory access that is a bottleneck. So that's why they are kind of roughly saying that's why they're very, very, very good. Also for neural networks. And neural networks have the same problem as the 3D models have, that they're so large that it's really difficult to do this stuff with the CPU. So even if we wouldn't kind of have a special instruction set and so on, a kind of a separate CPU with its own memory would still speed up the training process, right? Because anything that's not limited by the normal computer architecture. So we have this kind of trend going on that we need more and more compute to be able to work with these large language models. With large language models, it's actually not only the training but also the inference that is very complicated.
I was just going to ask how heavy is the inference operation?
Because of the size of the model, right? It's just like
with large language models.
Yeah, if it doesn't fit into the cache, then you need to read it in bits.
Okay, yeah. Got it.
To refetch, like next layers and so on. Another thing that these modern chips do very well nowadays. Nowadays, we're not working with graphics chips anymore. Nowadays, these chips are meant to do.
So even more purpose built for this specific task.
Yeah. So they kind of get ridiculous amounts of memory, and they can do things like model parallelization, where we have maybe 4 different GPUs, and then each of them kind of have part of the model. and then they interact with each other on the kind of border of that model. So we can split up a very large model into smaller pieces. And then these GPUs can live on the same motherboard. And then
so
do
they're
joint
physically
access.
close to each other.
Yeah, and then they do joint access to the joint memory. So
Yep.
there's no need to queue or anything like that. And that's also what Google did with their TPU originally and still nowadays. It's actually fairly interesting. There are pictures available online if you want to look at what the Google TPU really looks like and what the architecture is. It kind of makes sense from this kind of idea that we have different cores that all need to work with overlapping memory, and we want to minimize any kind of latency that happens there. So that's kind of the backstory. So there we have these large language models, but they require a lot of compute, and using specialized CPUs or GPUs or TPUs to do that compute gives us results a lot faster than traditional CPUs. And this is why, what is his name? Jason Cheng, the CEO, Jason Huang, the CEO of NVIDIA, was one of the main guests in both Google's keynote in Google Next and AWS's keynote in Greenland, which I thought was really funny. Because basically they were giving pretty much the same, he was giving pretty much the same speech for both of these competitors. And it really means that the world has turned towards using a lot of these GPUs.
And the market where NVIDIA and the competitors operate in, it has exploded.
Yeah.
Instead of making graphics cards, like for the purpose of graphics cards, there is a limited market with that. Well, I probably was saturated somewhat, but then you have suddenly a completely new field that's empty there, and these big operators like, let's say, AWS needs millions and millions of processors.
Exactly.
That's
And
just
that's kind
extra
of why,
sales.
and that's why the stock has gone up fairly nicely.
So who are the competitors of NVIDIA?
Intel talks a lot about their stuff. So traditionally, there was
AMD, Intel.
No, it was what was it? AMI, like the
was
what was
doing
it?
the when you boot up a computer.
No, it's AMD, yeah.
AMI sounds familiar, like decades
Yeah.
ago.
Let's see what other. So at least Intel nowadays, AMD doesn't, in my opinion, they're not that active, at least. Like for
more like CPUs.
Yeah, we don't buy GPUs, right? So we don't really know. So we're just going off the
I'm
news.
a Mac user. I don't buy hardware. I do buy hardware. I don't know what's inside.
Yeah.
So the end users might not
ATI was the, not AMI, ATI. Remember Radeon?
Vaguely.
ATI. So that was kind of one of the things, but that got purchased by AMD.
Radeon
so
was it ATI Radeon? Yeah.
Yeah, exactly.
Okay, coming back to me. Yeah.
Yeah, and then it's basically Intel. That's kind of roughly it.
Release date, yeah. Okay, this is a slightly old piece of hardware here.
Yeah.
Just reminds me.
Yeah. So it's interesting. It's a very specialized piece of hardware that requires a lot of hard science to get there. AWS, of course, have their own, and Google have their own chips, right? So Google has the TPUs, which are created in-house, and then AWS has their series of Trainiums and Inferentias and whatever.
Yep.
And they are, of course, created by the people from Annapurna Labs. So AWS purchased them, I think, 5 years ago or something like that.
So actually, where does AWS manufacture the chips?
No idea.
Yeah.
Some code, of course, it needs to be a silicon so a chip manufacturing company.
Yeah.
But then there are plenty of those. So
Yeah, the current world situation is such that they probably want to shift some production towards United States. I've heard about that.
They're doing production in the United States anyway. Lots of chip production. Almost the more specialized it is, then the more likely it comes from the US.
Okay, so that was the NVIDIA thing, and there's one more item here. The latest cloud computing statistics, recently updated.
Yeah, I just
Do you
wanted
want to say something about this?
Yeah, let me just pull it up because I can't see it from there. So yeah, the kind of the main thing is that the order between the biggest hyperscalers is still the same, right? So AWS is leading with 33.
Okay, it was actually
it's
okay.
still
That was
33.
Q1, but
that's Q1 2022. But then if you go a little bit lower, then you can see that it's actually the same. There, this one. So 33, 32, roughly. Remember that all of these are still growing, right? So even if it says that the market share has decreased, that doesn't mean that they have lost any users. It's still growing.
Yeah.
The second one is
scrolling up and down here.
Yeah, Azure with Microsoft at 2/3 of AWS. And then the third option is Google with 10% only. That means that AWS is larger than the two below competitors, and that kind of gives you an idea of the differences
How
here.
large that is.
Yeah. Another thing is that if you take a look at the regions and you take that into account, you can start to see that the regions of the individual competitors are a lot smaller than what AWS has to offer. So if you just kind of take these numbers that are here and then look at the maps of the different regions, then you kind of can understand that AWS regions have to be a lot larger than the rest.
So it's 60. This is about 65% in total.
Oh, yeah.
So 35 is for the small players.
And I guess the biggest bubbling under one is Alibaba, but that's heavily localized towards the Chinese market. Then we of course have Oracle. You have IBM, which have kind of been losers. You could also include like things like Salesforce into it, but yeah, it's kind of quickly stopped being interesting after the top three, and even
Actually,
Google being the top three. There's a big difference.
this is interesting from, let's say, someone who's switching careers or just getting into IT, and they are choosing. You cannot master everything, so except you, of course, but you cannot master everything, and you have to choose what is the most likely cloud service that I benefit from, and it has to be one of the big ones, unless you know that you're going to be employed by a company that is heavily invested in one of the smaller ones.
Yeah,
kind of
so there are two ways. There are two ways to think about this, right? So you can either think that okay, the majority of cloud computing happens on AWS, so
or you do it completely opposite.
You got the niche.
Specialize.
Yeah. So like I'm the only guy who knows how to work with Oracle, but then you need to find your kind of employer from a smaller set.
Yeah, and of course with IT, if you know something, you're fairly fluent with something. This knowledge is transferable. So if you know Azure, you know cloud, you know the mindset of how things work, then it's not going to be a big problem to learn something new as well.
Yeah. However, there is a kind of there's a pitfall in there that like a lot of things look very similar across
Of course.
the platforms, and then you might think that things work the same way, even though
But
they don't.
imagine the shift from you being on-prem hardware based, and then you
Yeah.
switch over to cloud-based solutions, and you have to change your mindset completely. Like treat your servers not as like a hardware piece of hardware, but just a thing that you get, and when you don't want it anymore, you just throw it away.
Yeah, I had this already quite a long time ago. I did a training where I think it was like technical essentials or something like that.
One day course.
Yeah, one day kind of quick intro to everything. And then when we talked about virtual machines, as I usually do, pull up the pricing page from AWS, because to be honest, often the slides are a little bit out of date, and it's easy to show how linearly the prices change based on size of the instance on that page. And then I got a question. This is all good, this cloud and the servers are there, but why are the prices per hour? Because we're buying it by the month anyway.
Yeah, exactly. So there you have the different mindset.
Yeah.
Instead of leasing something or buying something and using it for 3 years, you can use it for half an hour or less, depending on the task.
Yeah. No, it takes a lot. So we see as instructors, we I guess we see these kinds of situations fairly often, where somebody still comes from a very traditional on-prem environment, and then you really need to open their eyes so that they don't try to compare what they're doing on-prem with what they would be doing in the cloud. But they kind of need to create a new category of things for it to make sense.
One fun exercise is to start, let's say, 50 or 100 EC2 instances and show them that, hey, you have them here now. This will be expensive if you don't remember to shut them down, but you can have 100 servers up and running in 5 minutes or less.
In 10 seconds. I do it very often.
Depends what you get and what kind of initial things needs to be done. But yeah, they're in very short time.
It's funny.
All right.
It's an eye opener. Yeah.
So that was our news, unless you have something else there as well.
No, I'm very unprepared.
Okay.
You can throw me under the bus.
So we switch gears to this, which is data scientist, which I created. I created the image today, so we have something there at least in the beginning. And the word "mad" was used as to describe that this is a mad data scientist.
I like the cable that goes into that book.
Yeah, it's a weird keyboard as well.
Yeah.
But so if you ignore the minor details, that nothing will work in this diagram. You wanted to discuss a little bit about the job role of data scientist.
Yeah, so my kind of, or very often my topics go based on what I've just taught or what I'm ramping up for. And I just taught a data science class. And during that class, I told the students that data science has changed a lot. I was creating a data science master's program at the University of Helsinki 10 years ago, I think, roughly, something like that. And what we were considering, to be important things for data scientists then have pretty much become obsolete. So what is a data scientist, right? So there are many different job roles that have overlapping names. You would have kind of, if you have a kind of a continuum from practical jobs to theoretical jobs, on the theoretical end, you would have somebody like a machine learning scientist, right? So somebody who creates new machine learning algorithms and that kind of stuff. And then on the left-hand side, so kind of the more practical stuff, you would have something like a data engineer, whose job is to kind of create the data lakes, the permissions required for that, to make sure that data gets transformed in the correct way, and so on. So the original idea of a data scientist was some combination of these tasks. So not too technical, not too project oriented, still a scientist, but not really a machine learning scientist either. So something kind of, instead of doing purely theoretical work, something kind of more hands-on than that. So basically, the people that we see nowadays using Jupyter notebooks to use existing machine learning libraries to try to create some models and then put them into production, right? So that's kind of roughly what a data scientist would do. And what originally a data scientist did was fairly technical. So you have to, take a look at the distribution of your incoming data. You have to find how dirty it is. You have to clean it. You might have had to transform it, like if the algorithm that you would choose would require a normalized data set, and you would need to have to run that normalization, keep all of the parameters so that when you do predictions, you have to normalize the incoming data again, all of that kind of stuff. And then you needed to tinker around with a lot of machine learning algorithms. You maybe wouldn't create one yourself, but you'd be kind of up to date on what is going on and pick the correct ones and know the hyperparameters to do all of that. And nowadays, well, let me ask you that, because you've just taken the machine learning specialty. Nowadays, how much would you, after the workload of a data scientist, would be that kind of technical stuff that I just talked
about? That's a good question. I think the aim for cloud service providers is to minimize the heavy lifting, just provide tools that automatically take care of a lot of things.
Exactly. Right.
And I can already see by looking at some old course material compared to news course material that there are lots of new tools and lots of things that and services that makes moving data around a lot easier, and you can just basically have you have wizards that allow you to just point where your data is and it will figure out what needs to be done.
Yeah. So
and that's a good thing for at least for most of people.
Mm-hmm.
Why
would you
take
Auto ML?
Yeah.
Right. So Auto ML basically does machine learning on machine learning projects. So instead of the data scientist having to go and try out different hyperparameters, try out different algorithms, we basically just take an Auto ML system, like in SageMaker we have Canvas, in Vertex we have Auto ML, I think. In Azure we have something similar, which name I don't remember.
Yeah.
But they all have in common that you're basically just pointing the service to your data, like that's where it is in my data lake. And then this is the column I want to predict. And then it takes care of the rest. Right? So what is left for the data scientist?
That's a good question. What needs to be done? Well, there's always some technical stuff that you need to do, obviously, but it's maybe the amount of expertise that is needed is getting kind of smaller and smaller.
Yeah, it's just that it's a little bit like people have this preconception of modern airline pilots, that they basically just sit up there and press a button and then the plane flies itself. Is it the same thing with data scientists? So that they're just there to press the button and then everything else will work? No. Okay, no. There are other things that we haven't thought about originally that are important.
Give us an example.
So previously, machine learning projects were academic in nature. So we would have some old data set that we would then use to kind of show people that machine learning actually works.
But this new algorithm is even more, it's more efficient or predicts results better.
Like a good example is the MNIST data set, like the handwritten numbers data set that have been used forever to kind of do classification examples. So those never get used anywhere. But more and more we are seeing machine learning projects that are actually going to be used in production. And I'm not talking only about things like ad targeting, but things that really have an effect on people. For example, automated loan considerations by a bank or credit considerations by a bank.
Medical industry.
Yeah. Or medical is always difficult from the ethics point of view. Could be other things like even just a simple.
Hold on. For example, I was thinking about looking at X-ray pictures or some imaging and figuring out if there's a problem with the patient here. So that's kind of you can go through a lot of images very efficiently.
Yep. Yeah.
Not having to have a person do that.
Yeah. No, that's all good. But then there comes the situation of bias, right?
Yeah.
So
bias is a problem.
Yeah. Then this is not necessarily in the medical domain. We don't really see that often. But there's a huge problem if we see bias there. But like a good example would be, let's say, a loan application, yeah. And then we're using all information that is possible from a person to decide whether they can get that loan or not. And one of the attributes that we have is the year that the person completed their national service, right? So what's the problem with that?
Well, if you're young, then you haven't completed it.
That's okay. You probably don't want to give a loan to young people.
Yeah, most likely not. Then, well, if it's only about the year, then I don't get what you're aiming at. But
well, what would female
about male and female?
Right.
Yeah.
So males would have it because national service in Finland is compulsory for males, but for females, only a part would have it.
Yeah.
So we would introduce bias against women who haven't taken the voluntary national service. So we can't do that. It's not wrong. It's not right. Similarly, even worse is this example of this doorbell, which was in some university campus, and it was trained on white people only. And then whenever people of color would try to get in, just wouldn't do the facial recognition at all correctly. So what if that would happen, like an airport, where you would be, going through gates using facial recognition, and then if you happen to be a person of color, you have to go via the manual, just because the algorithm is not aware of or can't do that. And there are many places where this bias can be introduced. And we need to worry about the ethical consequences of that bias, so that we either have a way of getting rid of that bias, like as a data scientist, we can say that we can't use this attribute for prediction because it will introduce bias. And then also, when we're creating these systems that are based on predictions made by a machine learning algorithm, we need to make sure that they're ethical, that it is okay to do this in an automated way. So that's
How many of the bias problems are found out? You figure them out when you are already in production.
right. That's most likely the case, because the text cases
If you knew
haven't
it
been.
beforehand, you wouldn't end up in production.
Yeah, exactly. And this is fairly important because we have a lot of data that is actually very biased, especially in the medical sector. Like in the world in general, people from Western countries have better medical care. So if we try to use data from that and then apply it worldwide, it's not going to work. In reality, people are different from the data set that we're using from training. So identifying these kinds of situations and then knowing kind of a bag of tools, bag of tricks to work around those situations starts to be more and more important in what a data scientist is actually doing compared to just the technical stuff.
How would you detect bias if you don't want to have bias in your production model? How do you detect bias?
So there are existing bias detection frameworks.
How do they work? Where does that?
So they look at how much the different features affect the end result, and then they see what kind of distribution those features have. So if the feature distribution is uneven, and it maybe correlates with some other descriptive feature that we can highlight, like high risk, like sex, age, occupation, religion, then we get alerted by that. So if that if you think from Shapley, so if a feature has a high Shapley value and it shows this kind of problematics as a feature, then that's a bad sign. And then the rest, of course, is based on project work. When you're working with, this was actually taught to us in computer science ethics. Remember?
That was so long time ago.
Yeah. So but there is this requirement as a computer scientist, you need to know where the program is being used.
I actually now remember. I remember the ethics class. Yeah, I do remember.
Yeah, it's like you can't just hide behind I'm just working with data here. You need to know whether it's okay or not.
I have an example of that. Kind of. Well, you can tell me if this is bias or something else, or if this is discrimination. When you're applying for a loan, where you live has a high correlation to the your ability to pay back your loan. In Finland, for example, it's easy to tell. There are certain areas, if you have only one data point, which is one feature, is your address. That can be used quite efficiently to determine should you have a loan or not.
Mhm.
So is that discrimination, or is that bias? No, it's not bias.
No, the address itself is not, of course, biased. But then what you can do is you can take a look at the results.
Yeah, and you
Um,
actually cannot use that. You cannot use the address as part of the. You can use some certain when it's large enough an area, like
yeah,
not like cutting the whole country in two halves, but like
yeah.
smaller and smaller pieces. Then that might at some point you can use that information, but if it's too detailed, you are not allowed to use it.
Yeah, yeah, yeah. Maybe not ethically, but yeah. But one way that you can ensure is that you run your predictions, you give out loans, and then you take a look at the red flag features of the people who got the loans versus didn't get the loans, and then you know whether you discriminated, right?
Mhm.
So if you have like, you can see that from applicants, you have 60% male and 40% female, but people who got the loan were 90% male and 10% female.
Mhm.
And you know that you're discriminating based on
Yeah.
sex. And that doesn't need to,
Or if it's
it
based
doesn't-
on like the religion or
yeah, or whatever, those
yeah.
red flag kind of features.
Yep.
And this doesn't mean that necessarily you're using those features when you're doing the modeling. Those might be blacked out, but there are other
They just
dependent
derived
features.
from other. Yeah.
So you kind of, we have done a lot of sex prediction based on behavioral data. Fairly simple to define, to both get the age and the sex of a person just based on how they use like their mobile phone or,
Yep.
or whatever. So it's not about you explicitly knowing and using that. It's so easy to find those kinds of things via other parameters as well. So you just kind of need to make sure that that you're not not doing any kind of selections based on those even hidden features.
Okay. So what a data scientist does probably has changed a little bit because of the tooling and the way systems evolve. But if we take one step back, how do you become a data scientist? What's the path? One of the paths. How to become a data scientist?
Take your math classes.
Hmm. So you do. You need to. You cannot skip math.
Yeah, and
Obviously.
statistics.
That actually quite often you cannot skip math.
Yeah.
But what else? What would you study? Or
There's
how
so
would
many.
you go?
It is so vague nowadays. There are so many great online platforms where you can get all of the basics done. Of course, universities have great programs for data scientists nowadays. Whichever way you go, the actual studying starts once you work. It's kind of the longer you study, kind of the more complete degree you have in data science, the better, of course. The more you have been exposed to different kinds of frameworks and algorithms and so on. But in the end, the actual learning starts once you start to work. So
Yep.
you can use some of that information you have gained from courses, but it's still, you know,
And so
within
if you're
production.
already established yourself in IT, you are, I don't know, let's say software architect or programmer or whatever you want to do. And if you want to switch more to data scientist kind of role, then you just have to work with those projects.
Yeah, and it's quite it's like moving between let's say a systems operator and a developer is a lot smaller difference than between a traditional IT job and data science. It's a quite a big leap.
So how big
Especially-
is the demand? Do you have any statistics or ideas?
well, we can see it over at the instructor side. So those are the courses that are in highest demand, and we have the least instructors who are capable or happy delivering data science related courses. So it's definitely there. Even more with Gen AI, we're talking about this knowledge gap where businesses are kind of losing possibilities because their staff does not have enough information about how to use Gen AI.
Yep.
So again, Gen AI has just basically accelerated this need. and it's more and more less about technicalities and less about really the math, and more about these kind of more soft values, about the process on how to work with it. And currently, I don't think even think that the programs very well respond to that need. So there should be a kind of a like almost philosophy ethics type of course.
Are there any other challenges? If we talked about the kind of a little bit about the ethics, but like the bias, what are the other challenges with well, if you work as a data scientist? Can you come up with
Getting,
huh?
getting access to data.
So amount of data and the quality of the data, probably,
Just
and,
getting
or data in general.
getting access to it in general. That's kind of the number one problem with machine learning projects in general.
Do
So
you
like,
mean that the data doesn't exist, or you are not allowed to access it, or
yeah, so the way I teach it is like, let's say you're a data engineer, so you want to have some data for predicting some sales, right? So you call the manager of that department who takes care of sales. You ask them, do you have data of sales? And he said, yeah, sure, we. Yeah, okay. So then you go to their department's DBA or somebody, and then can I have the sales data? And then they're like, well, we only have 1 month of sales data in the database because, why would we keep the old ones? And then you go back to the manager, and then he says, yeah, the old ones are in archive. Then you go to the archives, and then you
tape
figure
archive?
out, tape archives. So you finally, after a lot of going back and forth and getting permissions, getting new usernames and passwords created in all kinds of different systems, you finally get the data. Okay, then you can do your model, and then you run it in production. Well, what if you need to update the model? You need to go through the same stuff again. Having proper access to data is the biggest problem.
Okay.
Now that we have data lakes, this is a little bit better. Data lakes, data marts, whatever, data meshes, whatever you want to call it. So now that we have this kind of single place where we staff our data, we get a little bit better with that. But still, just getting access to it. And you might be in a different department than the data owner, and they're not interested in helping, right? It's not like it could be like, I have other stuff to do. Go away. So this fairly big problem with getting access to data. This is like there was a book about problems in machine learning projects, and they had a statistic that 30% of all problems with machine learning projects are because you don't get access to data. Access, not technical access, but like permission. But yeah, it's a interesting problem.
Okay, but okay, accessing data is one. How about tooling?
I think we're nowadays we have so many choices.
So it's rather a problem of having to choose which tools to use. There are more than one way of solving the problem. You can use different kinds of tools.
Yeah. And then how to create a pipeline that, like, every single framework comes with their own pipeline option. It's like crazy. There's so much overlap in the tooling. It's worse than with DevOps.
Yeah. How about when you have a solution, how can you is for like a kind of a normal problem or a common problem with IT systems, and when it comes to writing applications and then running them properly in production, is scaling. So is scaling kind of a trivial problem for
If you use the
let's
cloud,
say you have 10 times more inference requests coming in? Is that a problem?
well, in the cloud, it's not, right?
It's a problem that has been solved many times already.
yeah, it will be kind of in a traditional environment, yes, but in the cloud, if you use the frameworks that are given by the cloud providers, then that's there are solved. Both training time and inference time scaling has been solved for you.
Because in on-prem environment, the scaling and scalability was a huge problem for various reasons, including the way the programs and applications were written.
Yeah,
So you had
absolutely.
your local knowledge about the request that comes in was from that particular client, and if you scale out, then yeah, you needed to use sticky sessions and things like that. And so you got, but that's the kind of a problem of the past. If you do things properly, you get scalability and high availability.
Yeah, Matt, I would say that that's one of the things that these modern cloud platforms have handled really well.
Yeah. Of course, you can do things incorrectly as well, but of course, we
Yeah,
advise against that. Okay, running a little bit out of time, but what else? I had a question in mind. How about following regulations? It's kind of the bias and ethics, but those are somewhat they are really important things, but might be a bit vague. But regulations, there might be some laws that you have to be aware of, depending
yeah,
on the area where you are, like physical, if you're in United States or Europe, and
yeah, exactly, right. So the EU has recently came out with Artificial Intelligence Act
yeah.
that then tries to put some kind of controls into place. So working according to those is then, of course, also important. But we are not really there yet, right? So this is something that's still to come, like in the next year or so.
How about then new algorithms? Because things do evolve. There's always something coming, something that we don't know yet about. So is that also unlike in the past, where you had to maybe you read about an algorithm and then you have to implement it by yourself?
Well, it's
So
about
instead of reading scientific papers and implementing those algorithms, are you just going to wait uh, for the cloud vendors to
yeah. So the
implement that
vendor
for you?
in the cloud, very often we're now looking for the final, final 5% of performance. We're not really interested in that. Um, just brute force it instead. So writing new algorithms or changing existing algorithms is very much an academic exercise. So in real life machine learning projects, you have a business metric that you need to get to, and the simplest solution that gets you there is the right one.
I mean, I didn't mean that we would ourselves come up with those new algorithms, but when they do, at some point there is a new algorithm, so we just wait for Google and AWS
Yeah,
to implement that, or an open source implementation, and then the tooling will follow. Is that
yeah, definitely. There's no point in like we don't often need in this business case. We don't often need that last bit of performance either in I don't necessarily mean technical performance, but also model performance, right? So we're kind of happy with whatever is good enough for the business case, and then we
and
stop.
that's actually the same with kind of programming as well and
Yeah,
architectures. Simple, straightforward solutions are usually
yeah.
really good
So
in the
like
long run.
always start with linear regression. It's like it's a simple solution and it works surprisingly often, or XGBoost. Um, and then if you go further, then you're fairly quickly in neural networks, and then it's not the algorithm anymore; it's the structure of the neural network that is important. And then there, of course, you have plenty of variability. But even there, we're seeing more and more transfer learning being used. So you're using a neural network that has been pre-trained on some generic amount of data, and then you just need to retrain it with your specific
Fine
data.
tune it with your own data.
Yeah, and then that's kind of where we're going. So less and less actual manual, implementations of either network structures or algorithms.
And now somebody says, then why do we have to learn mathematics if it's all the hard work has been done for us already? But mathematics gives good solid background to
and you have to
all
interpret
kinds of things.
You have to interpret the results. So you should know how things work, even if you don't have to implement them yourselves.
Yeah. And it really helps with other areas as well.
All right. I'm running out of time.
All right.
Interesting.
Let's wrap it up.
Yeah. Thanks a lot for the questions. It really helped. And thanks for anybody who's listening. Again, if you have any topics in mind that you want us to tackle, please send us a message. We also finally got our website out at deepdives-eu. That was a project that took a while. And try and take a look at if you can find a course that's being taught by us. Happy to include you. Just need to have some secret handshake with listeners and pamper them during our courses. But yeah, that's it for me. Thanks for listening. See you back.
See you next Saturday.
Yeah, roughly at 12 o'clock GMT.
It depends on your time zone.
Yeah, roughly at 2 o'clock Finnish time, or 1 o'clock in between in Central Europe. Thanks a lot, and see you. Bye.
See you. Bye-bye.